Hello everyone, welcome to our first video. I'm going to start with chapter 17, Angles and Polygons. I'm doing the lesson in English so that everyone can understand. Okay, if you have any problems, do ask me individually and we'll settle things up. Okay, if you don't understand something and you want me to repeat it in Maltese, okay, I will be code switching as well. We'll be talking in English and Maltese so you'll understand. So the first thing that you already know is that angles in a triangle add up to 180 degrees. We had started these in class already, okay? But some of you were absent, so I'm going to start off from the beginning of the chapter. Now, how do we know that angles in a triangle add up to 180 degrees? And we have this diagram over here, okay? I have this triangle with X, Y, and Z angles. Now, if you remember the alternate angles when we have parallel lines, the Z angle alternate, this angle would be equal to this angle would be equal to this angle, okay, because of that Z, because of alternate angles, okay? So this is equal to Y as well, this part over here. This angle here, because of the fact that these are parallels lines, this will be equal to this one here. And if you can see, X, Y, and Z, the three of them, okay, lie on a straight line. They add up to 180 degrees. So to explain it better, I'm going to say that CAB, okay, let CAB be equal to X, okay, CAB هنسموها X. Also, we know that ABC is going to be Y, and BCA or ACB is going to be a Z. It can be the case that in class I wrote it down a little bit different. It doesn't matter, okay? At the end, it's going to be the same thing. So we know that, let's call this P. PAB is equal to Y. Why are they equal? PAB. Why is this angle equal to Y? Because I have the Z angle, the alternate angles. Right? Now this one over here, okay, let's name this Q. So QAC is equal to Z. That is an alternate angle as well. So now what do we have? We have the fact that X and Y and Z are all on a straight, in short, line. So that means, and this means therefore, three dots means therefore, X plus Y plus Z add up to 180 degrees because they are on a straight line, okay? So something else you need to know, okay, is that the exterior angle of a triangle is equal to, and let's see, okay? So this is the exterior angle, the angle outside the triangle. Angle ACD over here, sorry, ACD, this is the exterior angle, okay, because it's outside the triangle. So the line CE has been drawn parallel to AB. This is the same triangle. This is the same triangle. What did I do? I created another line which is parallel to this one. Alright, so ħloqt line li huwa parallel ma' dan ta' hawnhekk. What is the value of ECD and Y? ECD. From E, go to C, go to D. What is this value? Okay, that value is exactly the same as this one over here. Why? Because I have parallel lines, okay, and there I created an F where this angle is equal to this angle, so this is B, and the reason is corresponding angles. Is B għax għandi corresponding angles. Now, what is the value of ACE E. What is the value of ACE? So from A, we go to C, and we go to E. Okay, ACE, I need this angle. Now, since this is parallel to this, I have a Z over there. You see, there's a Z. So this angle is equal to this angle. So if this is A, this is A as well. Okay, and the reason is alternate angles. Now, what does the following statement mean and why is it true? Let's have a look at this diagram over here. What happened to the exterior angle? This is the exterior angle. تراوا? The exterior angle it is equal to this angle plus this angle. تراوا? A plus B. Okay, it is equal to A plus B. So, an exterior angle of a triangle is equal to the sum means plus, of the other two interior angles. So if I have this exterior angle over here, it is equal to the sum of this and this. So when we add them up together. So if I have a look at this diagram here, this exterior angle is equal to the sum of this angle plus this angle. Okay? So over here you can write the exterior angle of a triangle is equal to the sum of the other two interior angles. Right? Next page. Something else you already know. Angles in a quadrilateral add up to, we know that they add up to 360. Why do they add up to 360 degrees? If you look at this diagram, okay, this is a quadrilateral. It has 4 sides. If we divide it, we'll end up having 2 triangles, okay? This triangle, the angles of this triangle add up to 180. The angles of this triangle add up to 180 as well. So 180 and 180 would give us the 360 degrees. So any quadrilateral can be split into 2 triangles. So the sum of the angles in a quadrilateral is, and write this one in this line, okay? Let's work out the first example together and this one. Let's work out two examples together, okay? And then you can work the rest on your own. So, I need you to find x. Okay, we have 3 angles over there. Oh, this is a triangle. I have 2 angles given, so I need to find the last one. It's not difficult. It's 180 minus 43 and 61 together. Use a calculator. 76, and the reason is that they are angles in a triangle. Y is the exterior angle, and we know that exterior angles add up to the sum of the other 2 interior angles. So this plus this. So 76 plus 43. 119 degrees. So 119 degree. Okay. Angles, exterior angle. Exterior angle of a triangle. Another method, okay, method مش بالفرصة. There's another method. You can work out 180 minus 61, and the reason would be angles on a straight line. That's also correct. Okay. I will do this question as well. So don't forget, these mean the angle is 90 degrees. This is a quadrilateral. It's a trapezium, a type of quadrilateral, and we need to find this angle. So we add up these 3 angles, 90 plus 67, and 360 minus that answer. 360 minus 90 plus 90 plus 67. It's 113-degree, reason being angles in a quadrilateral, in short. So try these on your own and we will be checking them out. So, properties of quadrilaterals, alright? These are different types of quadrilaterals. We have the square, right? You've got all your properties written down. You can just go through them. All sides are equal in length. Okay, you know what that means. They are all equal in length. All angles are 90 degrees. Two pairs of opposite sides are parallel. The opposite sides are parallel. Diagonals are equal in length. This is interesting, okay? Diagonal is this one. This is exactly equal to this one. Diagonals bisect each other at 90 degrees. So the angle between the diagonal and this diagonal is 90 degrees. 4 lines of symmetry. It has 4 lines of symmetry, okay? The lines of symmetry are over here. You've got one over here, 1, okay? 2, and where the diagonals pass, 3 and 4. Okay, 4 lines of symmetry, and rotational symmetry of order 4 as well. Then we have the rectangle. Opposite sides are equal in length. Opposite, okay, sides. All angles are 90. Two pairs of opposite sides are parallel. You know these, but okay, diagonals are equal in length also. So this diagonal is exactly equal to this diagonal, and they bisect each other. What does it mean, bisect? Bisect means divide exactly by 2. Okay, so if, for example, this is 10 centimeters, this would be exactly 5, and this would be exactly 5. So this part over here is exactly as this side over here, and this part is exactly equal to this part, okay? 2 lines of symmetry, you know where they are, 1 and 2, and rotational symmetry of order 2. Rhombus, all sides are equal in length, because it's like a square. The rhombus is like a square but tilted, okay? Opposite angles are equal. Importante, alright? The opposite angles are equal. This is equal to this, and this is equal to this. 2 pairs of opposite sides are parallel. It's like a parallelogram, okay? It is a type of parallelogram, very tough. Diagonals bisect each other at 90 degrees. Also interesting. The diagonals, and by the way, the diagonals are not equal now. مش بحال square kienu ndaqs. The diagonal, in this case, they are not equal, okay? This is longer than this one, okay? But they bisect each other at 90-degree angle. 90-degree angles over there. We have 2 lines of symmetry. Lines of symmetry adding on. We have one over here and one over there. And the rotational symmetry is of order 2 as well. The parallelogram is quite similar, but it's like a rectangle this time, but a tilted rectangle. Opposite sides are equal, opposite angles are equal, as we said before. So this is equal to this, and this is equal to this one. Diagonals bisect each other at 90 degrees again. So the angle between the diagonals is a 90-degree angle as well. No lines of symmetry, and rotational symmetry is of order 1. That means it doesn't have a rotational symmetry, just itself, okay? Because whenever we turn the page, we won't get the exact same shape as before. To get that shape, it has to be as it is now. So we've got more quadrilaterals. There's the trapezium. Okay, it's got just 1 pair of opposite sides. This is the important property of a parallelogram, that it has one pair of opposite sides. It has no lines of symmetry and rotational symmetry of order 1. So just itself, no rotational symmetry. The kite. Okay, a kite has two pairs of adjacent sides equal. The sides that are touching each other, this and this, okay, they're equal. And then we've got this equal to this one over here. One pair of opposite angles are equal. Only one pair. And which pair do you think? Is it this and this? Are these equal? No, they're not. This is the pair of equal angles. Okay. And one line of symmetry, which is this one. Okay. Rotational symmetry of order 1. So no rotational symmetry. Now I want you to use the properties we've gone through to try to solve these angles over here, okay? And if possible, give reasons as well. Try them out.